What's Gucci, everybody? It's AJ here again, and today I finally want to get into the big bad boys of C, and that is pointers. Pointers are very important in C and allow you to do many powerful things, as we'll get later on to see in this tutorial series. Now, I want to just say that in the little comment in the little box below this video, I'm going to have a link to a Dropbox note file, which will contain notes and a little follow along write-up presentation of what I'm going to talk about in this video, and for something for you to look back on while you study up on pointers. So, how I like to think of pointers is I like to think of my computer as a huge array, in memory at least. So all my memory in my computer is represented by a one-dimensional array that's billions of elements big. So it's like an array with 4 billion elements, and at each of these elements, some of them are blank, and some of them have very important memory in them, and some of them have nothing at all, like I just said. And basically, when you're creating variables, you're putting basically numbers or something, or a true or false value, at those locations which the variables look at. And what pointers do is pointers use those locations to change the variable or get the value of that variable. And they are basically used using two types of symbols: the indirection operator and the address operator. Let me put these in comments. And this is the indirection operator. I need to type faster. And the address operator. And what these do is that the indirection operator returns the value of the variable to which the pointer points to. And basically, let me show you my notes here for a second. What a pointer does is a pointer stores an address, or think of it as an index in the huge array. It stores an address to another variable, and inside that variable, it contains the value that you want. So if you're looking at this example right here with IPTR, right here, we have a variable that is a pointer. Sorry for my pausing. And this pointer doesn't contain a regular value like 1, 2, 3, -100, or 90. It contains an address. And this address refers to where the variable I is located in memory. And that it's the address of variable I, and inside that address is the value 90, or a regular variable that you would want to locate. Oops, I just farted. Now, let me show you guys an example here. So I'm going to create this integer I and name it 90, and what I'm going to do is I'm going to initialize a pointer. Now, a pointer is easily initialized, just like a regular variable, except for you add an asterisk. So again, I have to make the same type of what I want the variable to point to, and I'm gonna put the asterisk symbol right before I declare the variable name, and I'm gonna call it I, capital PTR, because PTR is nice because you're saying blank pointer, basically. PTR, short for pointer. And what I'm gonna assign here, I'm not gonna assign it to something like 90 or 100, because then I would literally be assigning it to the memory location 100, which would be bad. I don't know what's at memory location 100, but I want the I pointer to contain the address of the variable I. And how I do this is I use the address symbol. So what that does is, what I'm doing here is I'm assigning the I pointer to take the address of I, whatever the address of I is in memory. So not the value of 90, it's going to take the address of I. So wherever the value 90 is stored in memory, or wherever the variable, I should say, I, is stored in memory. So just to show you, I'm going to print out here, I'm going to print out the address of I, just so you can get a little visual representation of that. And let me print this out. And boom, as you can see here, the address of I is 229.3316. This is different than what is in the notes because it's different every time the computer runs where it allocates memory for it, where it creates a memory location for it. So as you can see, that is where the variable I is stored in memory. And in that address, the value 90 is stored. It's confusing, but if you keep on mixing with it, it becomes clear. Now, if I wanted to print out what value is stored at IPTR, I'm going to guess it's going to print out the same value that I just printed out because it has the address of I. It's assigned to the address of I. Now note, I'm just printing out IPTR with no address symbol or indirection symbol, no ampersand or asterisk symbol. And as you see here, it gives me 229.3316. The same thing, which is nice. So, as you can see, contained at this variable IPTR is the address of I. Now, let's say I wanted to print out the value of I through that pointer. All I have to do is I have to use the asterisk symbol again. Now, the asterisk symbol dereferences the pointer and it returns the value of the object to which the operand points to. Now, the object you can just think of as the integer, character, boolean, or whatever. In other languages such as Java or C++, where there are objects, there aren't objects in C, that may mean something different. But this should print out the integer value of 90. And as we run it, hey, we do get 90. So what this is doing is it's looking within IPTR, seeing that it has the address that points to I, and then going to I and printing out the value at I. Now, pointers are very powerful for many reasons. For instance, if I wanted to change the value of I could change that from the value from the pointer variable. Now, what I'm going to do here is I'm going to dereference I pointer, I'll call it, to 88. And what that is doing is that it's looking at the address of I, or whatever I pointer contains, and it's going to change the value at that address of I to whatever I set it to, so 88. So hopefully when I run this program, it prints out 88. And hey, it did. So as you can see, I was able to change the value of I. And now, actually, let me just show you guys. Let me print out the value of I. This allows me to change the value of I without actually using I. The only thing I had to do was I had to set the pointer to the address of I, but I was able to change it without assigning anything to I, which is pretty cool and pretty valuable in C. One last thing I want to note is that the address symbol and the indirection symbol are complements of each other in math. So if you put them together, they cancel each other out. So if I print this out, it will just give me the value of I pointer, which is just the address of the variable I. And of course, if I run this, boom, yes, I get 229.3316, what we have been getting all along. And I just wanted to show you guys that. But that is also important to know, is that they cancel themselves out, so you can't do anything weird like that. Also, I want to note that you can kind of think as the pointer variable also has an address as well. So I can print out the address of I pointer, which is different. It's 229.3312 instead of 229.3316. And basically, that's because pointers need to be stored in memory as well. But pointers contain addresses to other variables. So that is an important distinguishment. But they can also be thought of as variables that contain addresses. That's what pointers do. Variables Regular variables contain values, while pointer variables contain addresses. Well, guys, I hope you enjoyed this tutorial, and remember there are notes that I will post below in the Dropbox little thingy. And I hope you guys enjoy your day and enjoy this tutorial. I'll see you later.